Good morning, everybody. Namaskar. Millennial to Paul Millennium. Good morning. Namaskar to everybody. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 16, 2022, Wednesday, and this is 4:47 a.m. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ। आज तारीख मार्च 16, 2022, बुधवार का दिन, 4:47 a little late of course. Topic is same: quality, coordination, engineering project works, reliable engineers, communication, concrete, civil engineering work contracts, safety, health, environment, designs, construction methods. My email ID as usual is same: suraj_engineer@yahoo.co.uk, and you can check it here. That is suraj_engineer@yahoo.co.uk, and this is my name board: Chartered India, International Professional Engineer India, and this is my certificate: International Professional Engineer India, issued under IPEA, and this is valid for 5 years. And also this is Chartered Engineer certificate issued by Institution of Engineers and the provisions of Royal Charter of Institution of Engineers India 1935, and this is Membership Fellow FIE certificate, which is linked to corporate membership, which are AMI, MI and FIE. All titles are related to Chartered Engineer India use title. Everybody has this authority to use, and this is quality file, which speaks of quality a lot. Quality is a must, and this is coordination file, and this is your reference file for standard specifications for concrete, and this relates to Japan specifications of concrete. And meanwhile, I close this file Chartered Engineer India, and I also close this file Fellow of Engineers here, and I come back to quality issue, which is very important, and I talk on behalf of people of this country. Bharat India speaks about. I'm not speaking on behalf of government, I'm not speaking on behalf of myself. I speak as far as quality is concerned on behalf of people of this country who must get quality for what they pay, but they are not getting. And this is coordination issue, and which means coordination engineering is a question mark, and engineering coordination both are same. Projects is talks of, and what we say that we must understand quality issue, we must understand what is quality, how it works, and what relation we have got. And we say Bharat India speaks. And of course, if I say no, for timing I say Bharat India, I hide, and then I say quality and coordination. And quality and coordination are very important issues, which we can say, which apply. These two issues apply everywhere, on every work, on every material, on every process in entire world. And I can say, of course, I can't say quality is not good everywhere. It may be good or may not be good. That depends which country you are in, where it is. But in a general way, I can say there is a drop. There is a bit drop of quality in many countries, and also in our country is leader in drop of quality. I can simply say because of culture of working, because of mindset. And coordination relates to how do we work. Coordination depends on individual, it depends on groups, and it depends on concentration, it depends on seriousness of individuals, seriousness of professionals, seriousness of workers, and of course seriousness of owners, or you can say leaders in industries, in manufacturing, because quality relates to industry, it relates to manufacturing, it relates to entire culture. I'm talking of quality, which is job of everyone. Whoever works in industry, every person is responsible for quality, but those who are in lead, for example, engineers or supervisors, and those who are owners, or you can say leaders of industries, all are collectively responsible. And of course, there is a set of government everywhere. Government is installed in every country, in our country too. And it's duty of government also to make sure that country produces required quality. One cannot run away from responsibility by just saying this is private sector or this is that sector. Question is not of sector, question is of will. If I am not manufacturer, but if I am part of government, or if I am government, it's my duty to make sure that my country remains standardized It's up to me. I have my master controls. And we can say quality is not owned by anyone, it's owned by everyone. Everybody is responsible. Government is responsible, people are responsible, industries are responsible, and user is also responsible, I would say. On top of that, consumer or user of a product is responsible for quality. I cannot say no, this is very important part. Because but question is, reader is one single person, and one single person cannot act, cannot have that kind of organization with it, and cannot know everything about quality requirement. And we can say that is very important point. Temperature in Sri now is 19 degree and expected day temperature is 37 degrees and night temperature is 20 degrees, and just one information. Now coming back to work, I can say first of all, I can simply say that I have to open my eyes as an individual. I have to open my mind, keep it open also. And I have not just to talk or make claims, but everyone has to do, so I have to do. So to me, it's a direct relation of quality and coordination, and I should then say that if I want to ask quality, you get up, and if I ask coordination, you get up, which means indirectly I ask myself to get up. I cannot remain sleeping while quality is dead, art does not exist. That's what we have to relate to, like mathematical formula, it's directly proportional to myself. Existence of quality or degree of quality that's working is directly and proportionally, you can say, relates to my state of working, my state of thinking, and my state of being seriousness. Both quality and coordination. If I say no, I don't care about this, I just walk and walk and walk without quality, certainly I shall have no standard. So I have to be very serious, and usually I say in many writings, many talks, and it's not today, it has been for long, that we are not a serious society as this country, nation, you can say, this country, you can say. We are not serious people, we are non-serious people. And that's fact of life, that we as society take everything easy. Everything easy, and we feel happy, oh, it's easy going, no problem. Everything is easy, it's ease of working, it's ease of thinking. And when we like everything should be easy, this means loss of quality is also easy. Forget gain of quality or improvement on quality because we are not serious, and seriousness must be brought into action. So seriousness must be created. A state of seriousness must be evolved. Who can do it? I, as an individual, say I cannot work in my profession without quality and coordination. Of course, coordination is not something you can say, it cannot be measured, it cannot be seen, it cannot be named. It's a part of work. Same way, quality cannot be measured separately, it cannot be defined separately. It's a part of work. Job or work, you can say, product, you can say. That product is seen, that product is produced, that product must have certain parameters, certain inbuilt criteria, successful criteria, and that is called, in whatever way, quality input. People say input or output, I say quality input, and that quality input is not necessary. It can be defined in various ways, to what level this product stands, to what level this product qualifies requirement. There may be many requirements, but some people think only we take part of this. Depending on requirement, depending on price, we take more, we upgrade this. Likewise, it happens. It's therefore very important from professional viewpoint that quality and coordination is duty of everybody, is responsibility of everybody to some extent. It's a kind of, we say, if you work, you must do safely, we say. You should not meet an accident. No one should injure, and you should not work in such a way that every time you keep on working and getting tired. So the same thing, we should not get tired, we should not involve with accident, but we work successfully. Just like in safety, health and environment, we say safety is first, health, safety is first and then work. If you are not safe, you cannot work. So just like we say, safety is also a kind of quality system in work. Safety is also a part of system. Safety is also called engineering. Safety relates to health and health relates to environment and environment remains to group, and we can say it ultimately relates to. So we can say it is safe work, it's healthy work, it's good environment we have created, and that environment is not only for time being, that environment should be constant, it should be continuous. So we can say quality relates to safety also. There must be quality in safety and there must be quality in engineering, and we must have quality standards of working, we must have quality, even thinking also must have quality, coordination must have quality, and we cannot simply waste our energies or our time just for doing in random. We have to organize work in such a way that it repeats later on, and that's called production. Production, you can say you design some good, some product. Once you design that finally, and you can say now we can process, then you can say this is sample of this and sample. Okay, fine. Later on, if sample is approved, you have to produce so many thousands of such products, or it continues with some improvements later on, and this goes on and on. It's easy in production. In mechanical world, it is easy to work in factory everywhere. But when there, it is not only, it's not human resources, but their dominance dominance lies on you can say design, dominance lies on process. Most of that's automatic. But say which domination stands in construction or in work where human resources are in major percentages. Activity wise, I'm not saying money wise, activity wise, in civil engineering construction, generally human resources matter a lot. Human resources matter a lot because we have to use machine resources, equipment resources, material resources, and human resources. And without human resources, neither machine can work, neither metal can be used, and because nothing can happen without that. And that's really important part. So we have to be very important about issue of coordination, and issue of coordination is, you can say, it's something everybody cannot understand in right spirit, and that coordination engineering projects, public and engineers, as usually I name it, actually it's coordination everywhere that works. You think of engineering, or you think of normal life, or you think in whatever way you can think, I can think. Coordination itself goes in thinking also. Means my thinking is based on coordination, and my thinking also leads to coordination. So coordination is such a term that stands everywhere. Though it's a strong term in a vertical direction, we take graphically, but it moves in horizontal direction also. Otherwise, it cannot work. There may be graphics, we say x-axis, y-axis, and also there is z-axis, which is not seen. But work moves in vertical direction, in horizontal direction, as well as in perpendicular direction or spatial. This means coordination can stay everywhere. Though no is coordination, it can be co-abscissa, you can say, co-space, you can say. So it is coordination by term, but it can be co-abscissa. So abscissa means horizontally axis, and vertically we call ordinate. So in plan these are same. Planar arrangement is same, spatial arrangements can be different. And also we say engineering, because coordination just takes us from one point to another point, and then takes us to further another point, and these 3 points are connected and linked together. These cannot be, once we move on to them, it is to be stringed, it is to be serialized, and we can say we have moved this way. This is a part of process, or I can say it's a part of process train, and we continue moving on points which relate to some item. That is called if it works, okay, it is coordinated, or these 3 points coordinate together, and if they do not work, then we have to change either of them, so that either figure is formed or we move on further in process with results. Of course, not just we connect someone without any relation, and that doesn't work. And therefore we can say it is coordination engineering. It works, we first design it and we test it test it randomly or mock, and specifically for statements, and we can say okay, it is coordination arrangement. That arrangement I am looking for. You can know design of project, you can do designs and you know how to do it, but coordination, once you do it, if even if it doesn't work, you understand it can work and it works, and that is coordination. This means every point, every design, every part of that arrangement, that process works, and all works together, dependent, not inter. You can say all 4 points have no relation to each other, then we cannot say it is coordination. It is then every 4 points, suppose every point is there, 4 points are no relation, but within themselves there is a relation, so we can say there it's different coordination. In engineering coordination, you can say there's no need of defining coordination, but it is a must that we must understand coordination, and which is a kind of, if we have body here, my body is working, this means every part of my body is working, right? If this system is working, every part of the system is working. And if we work together, suppose we are a group of 3 or 4, say, we all have to work. I cannot say that we two work and we two don't work. It can't be successful. There shall be delay, or there shall be, you can say, what cannot be completed. It's therefore very important, my dear friends. Coordination engineering is that it cannot be taken for granted on projects, and we can say if we want to understand where to do job, we have to understand this terminology also. We have to understand quality and coordination. We have to understand what are projects. We have to understand what is value of engineers and also value of communication. And how do you think materials are important in engineering and production, or in construction and contracts, what's value of contracts. These terms are all related practically. Materials, you can say contracts, and we say dealings with humans and machines, and what method we adopt. These are very important. These are separate type of topics or subjects which we learn in engineering. If not during education time, we understand them in work time. Education takes to work, and work takes to further works of projects, and projects go on further and further. We deal with contracts, we deal with safety, we deal with engineering, and we deal with organization. And everywhere coordination is required. Somewhere it is design coordination, somewhere it is you can say machine coordination, somewhere it is human coordination, and somewhere it is scientific coordination. Means coordination works everywhere, and there can be errors in coordinating also, and these happen, which leads to mistakes or errors. If we do not understand coordination correctly, then we can coordinate incorrect items, and that these don't work, or these can cause accidents also. So what to coordinate, where to coordinate, how to understand that, how to design, how to analyze, how to synthesize. All these issues come under purview or ambit of coordination, and until we do not know everything about something, until we don't know every analysis, until we know what we are going to do is right or it's not right, we have to understand every point, and that's important here is. Of course, I was talking about, for example, we're talking about I by chance took this file, specification of concrete. This is Japanese specification, and it gives a lot of information. And this is standard specifications for concrete structures, 2007 Materials and Construction. It is it is from Japan Society of Civil Engineers, and I was just referring this to you for additional knowledge. I have not gone through this file, but let us move on to this to understand what we can get from this. That information is very. I talked to you about this index of this, and now we are somewhere here. You can say was talking of here what we are, you can say in first way. Yes, it was flow of work. We discussed planning related to design. Planning leads to designs, and designs lead to construction, maintenance. Now, planning is not project planning; is project. It's different kind of planning. Means we have to first decide what we have to do, and if you decide that okay, this project in its initial stage we can understand, and we can afford this, then it's okay. We go to designs, and when designs are ready, we go to construction, and the construction is ongoing, then it goes to delivery of project and maintenance. This is called flow of work, which is very, very common. And there are standard specifications for structure, design, giving all these specifications we just can hand. Also, this is a flow chart. This is our plan of, means it is flow chart of, you can say we discussed yesterday, that is work steps described in specifications for designs. What is design specification? And this was very clear. You have to, here use and function of structure is plan. It says that the plan for a structure, specifications for design, there you must have, then specifications of performance requirement you must have, structural planning, and all these specifications for designs covers all these specifications for designs, covers performance requirements and structural planning. And also then we have plans, it goes to structural planning. After that goes to design plans, and design plans, which means structural format materials. Structural format materials used dimensions of major elements, construction method, etc. And we name it as structural format materials use dimensions of major elements, construction method, etc. is called. And then we go to design of structure. Here is a plan for structure. Means we planned in this way. We planned using specifications for design, specifications of performance requirements, and structural planning, and we design plans. And then we go to design of structure. What should it be? How it should be? Specifications for design we must have specifications for designs, which should include a specification of structural details, structural details, cross-section, materials, bar arrangement, and performance verification for structure. That's the coverage. And then we also say, okay, we go to design drawings, everything is known, performance verification is done, and then we have to produce delivery item, and these are design drawings and other materials. Structure, materials, construction method, maintenance plan, etc., etc., etc. You can say goes on, and it then goes to implementation, and that's called construction of structures. This is work steps described in specification or design. Flow of work. In flow of work, we have gone understood process of design. How, what's the various process. Also, role of and deployment of engineers, as we said. This is also very important point, and it's important to say just in brief. I remind to produce and maintain a reliable structure that meets performance requirements. Engineers involved should have a capacity to carry out work and high level of ethics, maintenance of or observance of high level of ethics. In planning, design, construction, maintenance of a concrete structure, engineers should make appropriate decisions under varying work conditions. Therefore, engineers with required technical skills should be deployed according to level of difficulty of work in planning, design, construction, maintenance. Therefore, responsible engineers not only with required technical expertise, but also with responsibility and authority. Authority should be deployed in organizations of owners, consultant, and contractor. And then we can say, and then we say, okay, this is a design flow. Then we have to go to after this, that is planning of structure, let us say. And this says the maintenance of structure, and this says work steps described in specifications for material and construction, and which is construction. Here is planning of structure we done, design of structures we have done. Then we start construction of structure, which covers specifications for materials and construction, planning, verification, and approval, which says okay, after verification it is construction, and it is also linked to quality as well as inspection, because inspections means generally is a part of both construction and quality. And then we have to say we have constructed, and we then go to as-built drawing and construction records, which follow up to. Then we have the maintenance comes into our view, and that's flow of that. Then other one is here this graphs, which is work steps described in specification for maintenance. Means it's not construction, it's maintenance specifications. Though we don't even, in our world of construction, we don't even, but it's a part of work. It says planning of structure, means design plans it gives. Planning of structure gives you design plans. Design of structure gives you design drawings and other materials. So planning of structure is design plans, and design of structure is design drawings and other materials. And construction of structure gives you as-built drawings and construction records. So these are deliveries. We can say design plan is a delivery, design drawings and other material delivery, as-built drawings and construction deliveries. Design plan are delivered by planning of structure, design drawings and other materials, so designs of structure, and you can say as-built drawings and construction of structure. Then it goes to maintenance of structure. Now we are talking of maintenance, and which covers as far as specifications for maintenance are concerned. What these are? Specifications of maintenance cover entire scenario, and that is investigation and deterioration, prediction and evaluation. That is maintenance plan. What shall we maintain? This means investigation, deterioration, prediction and evaluation, which takes us to remedial measures required or not required, which it will tell us. The investigation shall give, based on records, it needs we have recording here and assessment also both. And then what is required, what's not required, that's remedial measures, and that we have to see in maintenance. It's necessary or necessary, depends on what's the age of structure, how does it work. It's new or old, or retrofitting is required, or rehauling is required, or new structure is required. And the implementation of remedial measures, then also what there's no one remedial measure, can be many remedial measures, depends on so many factors. And we can say storage of maintenance records. We have to then, just like we say as-built records, we have to can say storage of maintenance record. What we maintain, that must be on record, and so that it can be helpful in future, and it's really useful. So say work steps described in specifications for maintenance. It is that one. Now what you say now, we said technical skills for engineers. What engineers technical skills must be, we have studied that one, and it should be engineer's qualification authorized by this Japan Society of Civil Engineers. What it should be, said was qualification for executive professional senior engineers, which is considered lead engineer, VV's command engineer or authorized engineer. Then it is senior professional civil engineer, and then it is can say professional civil engineer and associate professional engineers. What are the expectations of society from them? Executive number one must be having highest level of knowledge, and senior must be independent knowledge. You can say multiple fields knowledge, as well as professional civil engineer, which must have good knowledge, engineer's knowledge, and experience in at least one special field. Where associate professional associates means with required basic knowledge. You have to civil engineer with required basic knowledge who can carry out assigned tasks, which is, you can say, start in life as a professional. Then you have to go to senior professional level with, you can say, multiple fields experience, or a kind of coordination engineer, you can say. And then highest engineer level, executive professional engineer, Japan's leading civil engineer, and high level of experience in highest field. Okay, that's just indication of what level of competency one should have in a system for ensuring reliability, which is a very important part in world of engineering. And without reliability, we can't do anything. And it says many groups are involved in planning, designs, construction, and maintenance of a structure. It covers all planning, design, construction, and maintenance. And many groups are involved in order to ensure high reliability of structure. In each workplace, in each work phase, organizations involved should play their role, providing know-how, respect to know-how, and assuming due responsibility. Assuming due responsibility, that's the most important part. To ensure reliability in designs and planning phase is two independent groups should basically check design. Two independent groups should basically check design so that our design remains reliable with full confidence after design and check by design company, engineer or engineer of contractor, of course. Engineers of contractor should recheck once you get design delivered. It says contract employed engineer should recheck design or request a third party to check design. We may say a kind of review, or also say proof checking or reliability checking. Then full skilled engineers should be selected for checking so that safety or other reliability parameters may be satisfied. Here is design safety, work safety, future safety. It's not safety during work. Means use safety means whatever we do, whatever product we deliver, in use it should be safe, and this should be for entire life of that product. I'm sorry. Design drawings serving as a basis. Design drawings service as a basis for contracting should carry signatures of responsible engineers of two groups that assume responsibility. That's important part. Means it's not simply check it, you have to take responsibility also that you having gone through this all activity of checking or rechecking. You also come as a stakeholder in this responsibility. In construction phase, reliability is ensured through quality working, quality organization, quality management by contractor, and quality verification by inspector independent of contractor. Means a kind of third party or a party related to neither contractor nor to engineer, and that independent party of contractor should inspect. Independent party work on behalf of project should check. Inspections have generally been conducted directly by owner and consultant. Owner consultant completed structures should be inspected wherever possible. If inspecting completed structures is impossible, inspections should be conducted while structure is being constructed. Means in stages of every member and every item involved or preparatory work is involved, inspection should be conducted. That's what it says. If owner cannot directly inspect to ensure reliability in design and in planning phase, two independent groups should basically check design. After design and check by design company, engineers of contractor should recheck that design or request a third party to check that design. Fully skilled engineers should be selected for checking so that safety or other reliability parameters may be satisfied. Design drawings serving as a basis for contracting should carry signatures of responsible engineers of two groups that assume responsibility. In construction phase, reliability is ensured through quality organization by contractor and quality verification by inspector independent of contractor. Inspections have generally been conducted directly by owner or consultant. Completed structures should be inspected wherever possible. If inspecting completed structure is impossible, inspection should be conducted while structure is being constructed. If owner cannot directly inspect structure under construction, owner may request an agent independent An agent independent of contractor adopting as many highly reliable methods as possible can reduce workers required for work element required for quality organization management and inspection. In cases where adopting not a reliable methods is you can say inevitable, level of quality organization management should be raised or inspections should be conducted more frequently to improve reliability. Inspection items and decision criteria should be specifically presented at a time of contracting because they greatly affect quality of structure and construction cost. Ensuring safety requires regular investigations. Ensuring safety requires regular investigations. When defects are detected, decisions should be made as to remedial measures. For decisions making concerning remedial measures for extremely difficult deformation, listening to options of engineers with high skills who have experience in numerous cases is important. In order for a system for ensuring reliability to work properly, people or organizations with technical skills fit for specific work should be granted explicit responsibility and authority and assigned to work. Compensation for work and time required for work should also be provided. General requirements. Now we come to general requirements. So that contents of this book, content of this specification commence with that in chapter general provisions. It says standard specifications for concrete structures, that is materials and construction. General requirements hereafter referred to as construction. General requirements of this specification describe basic concepts for construction of concrete structures specified in design drawings and specifications. As a general rule, to construct a concrete structure, it is necessary to develop a construction plan based on design drawings and specifications provided. Within that contract, construct structure in accordance with construction plan while performing proper quality control or quality requirement compliance, and inspect structure to confirm that structure has been constructed in accordance with design drawings and specifications, and also we can say good industrial practice. We can add that one. It's not possible to develop a rational construction plan in accordance if it says if it's not possible. If it's not possible to develop a rational construction plan in accordance with design drawings and specifications or whatever else is necessary to be included in that work, it is mandatory to revert or go back to design stage and modify conditions set out in design drawings and specifications, and this is very important content of this talk. If it is not possible to develop a rational construction plan in accordance with design drawings and specifications, it's very important announcement. It's very important question. If your drawings, your specifications are not implementable practically, that's a question mark. It's mandatory to revert to design. So what we have to do? We have to go back to design and rethink on this, modify it so that it suits to circumstances, it suits to environment, or it suits to ease of construction. It's a very important point. It's mandatory to revert to design stage, modify conditions set out in designs, drawings and specifications. And that's what I say. If you keep on coordination, you won't meet that problem when you coordinate at every stage. And coordination is not just spelling or just correspondence, it's gross engineering part. Actually, it's a real methodology how to connect various other methods. It's methodology which connects various other methods, and that's called, you can say, this is coordination. You can say that method connects other methods in plus and minus or in front or back, and that's called coordination arrangements, coordination engineering. For ordinary concrete works, very ordinary concrete works, it's advisable to refer to standard specifications for concrete structures. What it says, standard specifications for ordinary concrete, not special. Standard means general, or you can say proven specifications for concrete structures. Materials and construction, and that is materials and construction. Construction standards, hereinafter referred to as construction also. Construction standards of this specification, and standard specifications for concrete structures. Materials and construction, that's why it was materials and construction, and other it is materials and construction, concrete structures, materials construction. Inspection standards, materials and construction inspection standards, and there was previously materials and construction standard. So they were construction standards, and here is inspection standard, hereinafter referred to as construction inspection standards. So two terms, same terms. One is construction standards, where materials and constructions being involved, and same way inspection, where materials and construction is involved, inspection standards, and which we can refer to as construction inspection standards. One is construction standard and other is construction inspection standards. For concrete works described in standard specifications for concrete structures, materials and construction, special concretes, they are often referred to as construction special concrete of this specification. A construction plan shall be developed with reference to provisions of construction special concretes of this specification. Now little commentary, let us see what it says about commentary. It says, let us read, construction, that is general requirement of specification, describes basic concepts for development or for developing a rational construction plan and carrying out construction work in accordance with construction plan in order to construct a concrete structure specialized in design, drawings and specifications on assumption that structure has been designed appropriately so that performance requirements for structure can be met. Design drawings, this is performance requirements for structure to be made. This is an important point. Performance requirement means if it's not performable, there's no meaning of that. It is performable, that's what we say our target is. Design drawings and specifications for a concrete structure which are result of design developed to meet performance requirements for structure. Show structural drawings, reinforcement drawings, structural drawings, reinforcement drawings, concrete properties and materials, mixed proportions and other details required or needed meet these properties. Details required to meet these properties. Its basic requirement. It is a basic requirement, therefore, to plan construction of a concrete structure in accordance with design drawings and specifications. In cases where a construction plan can be drawn up in accordance with construction standards or construction special concretes of specification, it may be assumed that concrete structures as described in design drawings and specifications can be constructed. There's a figure says it illustrates a scope of construction. I will see that after that. And construction plan drawn up in accordance with design drawings and specifications must be confirmed and approved before construction is started, and that plan must be approved. All tasks in construction process must be performed in accordance with construction plan after proper quality checks or quality examinations are done at each stage. Completed the structure is taken over by owner after it is confirmed through inspection that structure has been constructed as designed. Conditions assumed for construction planning at design stage may differ. This is an important point here. Conditions which were assumed, for example, which are assumed for construction planning at design stage may differ from actual construction conditions. In such cases, conditions such as selection of materials, mix, design and plans at each stage of construction are altered to an extent but extent that properties indicated in design drawings and specifications are achieved. If, however, it is difficult to develop a rational construction plan while achieving properties indicated in design drawings and specifications, it is necessary to return to design stage and alter design and prepare new design drawings and specifications so that performance requirements for structure can be met. And this is very important consideration, very important para for designers to understand that if your work is not constructible, it's no use. Construction contracting standard, construction contract construction standards of this specification applies to ordinary concreting that involves few or no special requirements. Construction inspection standards of this specification describes an inspection system corresponding to such concreting. If these requirements are met, it may be construed that the requirements described in construction general requirements of these specifications are met. Construction special concretes of this specification deals with type of concrete that have proven performance but are not covered by construction standard of this specification. It is therefore necessary to fully understand indicated requirements and incorporate them into construction plan. What is that now? Let's see. Here is design and there is confirmed approved. You can see arrow here, dotted line arrow. Design goes to construction planning and construction planning goes to confirmed approved. These are linked together, and then we have a gross, you can say gross dotted line here, gross dotted line which covers many process, and in that confirmed or approved links to design. Also it links to construction planning. So designs, construction planning, which links to confirmed, approved, both, yes or no, both. If it is no, we have to go to construction planning. If it can be done, and we can say let us go to design. In that case, if construction planning is confirmed, approved, now it goes to construction after yes, and then it's linked to quality control, and construction is linked to inspection directly. It goes back if it doesn't work. Then it goes to maintenance after inspections or standard specification for concrete structures construction. Scope of construction, general requirements and flow of concrete structure construction process. Now let's go to different definitions. Terms used in standard specifications for concrete structures construction general requirements are defined as follows. There is verification, there is inspection, there is quality control, there is domain engineer, and you can say domain engineer. So let us see one by one what it says. Terms used in standard specification of concrete structures construction general requirements are defined as follows. Verification, act of judging whether something meets performance requirements through experiments using full scale specimens, empirically and theoretically proven analysis methods. Other one is inspection, act of judging whether quality satisfies required criteria, and control, and that's quality control, effective and organized technical activities for quality assurance or requirement performed at all stages of construction work in order to economically construct a concrete structure that matches required or intended purpose. Domain engineer, a person who is authorized by responsible engineer and perform part of its responsibilities. Commentary on this says, this writer says, quality control which is carried out to make a concrete structure that meets performance requirements should be performed by a method that is as economical as possible. A person who has been ordered to assume part of responsibility and authority of contractor for particular construction work to be carried out in connection with construction of concrete structure is referred to as domain engineer. I repeat, a person who has been ordered to assume part of responsibility and authority of contractor for particular construction work to be carried out in connection with construction of concrete structure is referred to as domain engineer. Before carrying out construction work, it is necessary to clearly define scope of responsibility and authority of each domain engineer. A domain engineer must be a person who is qualified as a first class civil engineer certified by Japan Society of Civil Engineers first class civil engineering works, executive organizing or managing engineer Japan Federation of Civil Engineering Works, execution managing engineers association, chief concrete engineer Japan Concrete Institute, concrete engineer Japan Concrete Institute, key technicians specializing in a particular type of construction related work or a person with equivalent expertise. Chapter 2, Construction Plan. What it says: an appropriate construction plan shall be prepared to construct a concrete structure indicated in design drawings and specifications. Construction plan shall meet requirements for construction work concerned and be approved by owner after it is confirmed that concrete structure indicated in design drawings and specifications can be constructed. So this is design approval in fact. This construction plan shall meet requirements for construction work concerned and be approved by owner itself after it is confirmed that concrete structure indicated in design drawings and specifications can be constructed. Has a commentary on that also. Preparation for an appropriate construction plan and carrying out construction work in accordance with construction plan are essential for construction of a concrete structure that has performance attributes, namely safety, serviceability, restorability, durability specified at design stage. These are reliability coefficients, reliability attributes, and which are safety, as we said in the first go, safety, other one is serviceability and restorability, durability, and in combination of these we can call it reliability in fact. This figure we saw shows flow of process from design of a structure through development and approval of a construction plan to construction. In order to, in order to construct a concrete structure indicated in design drawings and specifications, appropriate concreting method and construction performance of concrete must be determined, and a construction plan is drawn up taking into consideration construction requirements, namely quality requirement, construction safety requirement, economy requirement, construction method or construction period, and environmental loading requirements. Information to be provided by designer to contractor. Information to be provided by designer to contractor. Information to be provided by designer to contractor consists of characteristics value for concrete determined according to performance requirements for structure. What says information to be provided by designer to contractor consists of characteristics values for concrete determined according to performance requirements for structure, maximum size of coarse aggregate, and reference values related to concrete mix proportions such as cement content and water to cement ratio. When developing a construction plan, it's necessary to concretely specify concrete performance requirements and mix proportions determined at design stage. Contractor prepares a construction plan in accordance with design drawings and specifications and submit that plan to owner. After construction plan is approved by owner, construction work is carried out according to approved plan. Structural performance does not need be verified again if construction conditions determined in this chapter are same as conditions assumed at design stage, or if a standard construction method indicated in construction standards section of this specification is used. If, however, actual construction conditions differ significantly from conditions assumed at design stage, performance of structure must be verified again on basis of actual construction conditions. If verification has revealed that structure does not meet performance requirements, construction plan requires to be altered according to situation. Here is construction plan, what it says. Important one, and you have to read this for time being. I'll be back after 5 minutes. I have to go up and come back. Just just 5 minutes, please. I'll be back. Okay, gentlemen, let's continue. Determination of structural details. Now this is design of structures, and it covers many aspects, and that is what its name is. This is, you can say, long. This is C211, flow of structure designs and construction planning. Structural designs and construction planning, and this is here performance, requirements for structure and requirements for construction work, both. Performance, requirements for structure and requirements for construction work, these are combined together, which goes to design of structure as overall and determination of structural details. Design of structure, and also you can say determination of structural details, which are covered in which covers, determination of structural details covers determination of concrete details, determination of concrete details, determination of reinforcement details, and determination of construction method. These three items go to determination of characteristics value for concrete. Determination of characteristic values for concrete. Now, determination of maintenance details. So this is for construction and designs, and this is for determination of maintenance details, which relate to design of structure and determination of structural details. It is verification related to earthquake action. Verification of performance is required, and that is verification relates to earthquake actions and related to safety and serviceability, and related to environmental action related to initial cracking. So what is that? That is design of structures within itself, and verification of performance of structure, and that is verification related to one item is earthquake action, other item is safety and serviceability, then environmental action and initial cracking. All these items are required for verification. These must be successful, and that is verification related to these items. And if it is okay, it goes to design documents, specifications, and inspection plan, and all these come within ambit of design review. This is a design review has been linked to this, and both above and below is linked to design of structures, that is the design review, and it relates to design drawings, specifications, inspection plan, and then construction planning. And here we can say what we do after design document, specifications, inspection plan goes to construction planning, and here is, you can say, what we say here is determination of construction methods, which is linked to determination of manufacturing method, and which is linked to concrete mix design. So determination of concrete methods and determination of manufacturing method. Let us say determination of concrete method, which is linked to determination of construction performance. Determination of construction methods include transportation, reinforcement work, form work, placing, compaction, curing, joint work, finishing. Very simple. What says? Construction methods, transportation, reinforcement work, form work, placing, compaction, or we call compaction, somebody call consolidation in a universal language, curing of concrete, joint work, concrete, and finishing. Now, determination of construction performance, and that is linked to concrete based design also. Determination of manufacturing method links to concrete mix design also. Then other items, environmental and safety planning If we say other items are these, as we said, preparatory items, and also post concrete, that is, for example, curing and compaction, joint work, finishing, all these are related to quality control, planning, inspection, planning. Ultimately, we say concrete mix design, selecting materials, selecting mix proportion, and then verification of concrete performance, which is after saying yes goes to determination of mixing portions, proportions, and we can say confirmation of construction plan. And then we give final say okay, start of construction works, and this is what we say flow of structural design and construction planning. Considerations in construction planning. Considerations in construction planning. Construction plan shall be prepared taking into consideration environmental conditions and construction conditions at construction site. Environment conditions and construction conditions at construction site. Giving considerations to construction safety and environmental loading, and developing plans for details such as overall schedule, construction methods, concrete manufacturing methods, concrete manufacturing methods. So there are 4 items for, can say these are what developing plans for details such as overall, that is schedule. Schedule, we say there are many levels, so it is tasks or must plan. We can say overall schedule, construction methods, then concrete manufacturing methods, construction performance of concrete, concrete mix proportions, quality controls, inspection, environmental impact and safety. There's a commentary also everywhere. Let us see what it says. That can also give much more benefit to make clear all these points. A construction plan must be developed in due consideration of quality achievement. In due consideration of quality achievement, construction period is also an important point here. In addition to quality achievement, construction period, safety, economy, and environmental impact, so that construction can be carried out successfully. Safety measures against risks expected at construction stage must be carefully studied in advance. Environmental considerations, environmental conservation plans must comply with all environmental laws and regulations, as well as standards related to construction work. It's also good practice when preparing a construction plan to take into consideration items for which there is as yet no standard to meet, so that environmental loading can be minimized. There are certain examples here of items to consider when drawing up a construction plan. Examples of considerations in construction planning. Let me blown up. Plan for transporting and receiving concrete. This is one part. Then haul road plan, its placement plan, compaction plan, finishing plan, curing plan, jointing plan, reinforcement work plan, formwork and false work plan, environment conservation plan, safety and health plan, others. Just about 12. Let's see what it says. Same points as we discussed before. What is this item is plan for transporting and receiving concrete. This is construction planning. Plans for assigning and operating agitator trucks, haul roads, on-site tests, inspection areas, inspection of concrete mixture portions, slump, that is slump, air content, water content, water to cement ratio. Then is haul road plan for concrete, hauling method, concrete supply capacity, standby pumps, trucks, etc. In placement plan, construction organization, organization chart, placing intervals, hourly placing rate, safety, etc. That is placement plan. And then compaction plan, type and number of vibrators corresponding to hourly placing rate of concrete, personal requirements, preparation of standby vibrators, replacement personnel, etc. Compaction plan it is. Then finishing plan, skill level of finishing required or workers, skill level of finishing workers, plan for time of finishing, finish accuracy plan, confirmation of equipment to be used for finishing work, etc. Then curing plan. See, every activity is planned here. Time of initiation of curing, curing method, confirmation of curing period, confirmation of curing equipment, confirmation of persons responsible for concrete curing control, etc. Then jointing plan, jointing method, treatment method, equipment, time of jointing, etc. Reinforcement work plan, reinforcement work plan, confirmation of reinforcing bar diameters, spacing, method for ensuring concrete cover, assembling method, type of reinforcing steel, fabrication method, skill level of reinforcement workers, etc. Formwork and false work, design of formwork, that is lateral pressure, confirmation of formwork materials and false work materials, formwork designer, timing of form removal, timing of false work removal, lateral pressure control method, etc. There's environmental constructions, let's say lateral pressure, confirmation of formwork materials and false work materials, formwork designer, timing of formwork removal, timing of false work removal, lateral pressure control method, etc. Environmental conservation plan, washing water, curing water, drainage of bleeding water, etc. Checks on noise and vibration, dust and environmental impact, etc. and around job site. Safety and health plan, confirmation of matters related to safety, confirmation of matters related to safety and health of construction workers, others, confirmation of troubleshooting methods, etc. Determination of, that is construction plan going on, determination of concreting method, determination of concreting method. It's important one, determination of concreting method. Appropriate method of concreting including hauling, placing, compacting, hauling, placing, compacting, finishing, curing, etc. at construction site shall be selected in due consideration of, of influence on quality of concrete in structure. In cases where a new construction method that is thought to be more suitable for construction work concerned, that is standard construction method assumed as design stage is used. Influence of new method on quality of concrete in structure shall be ascertained through experiments or by other means. Inverse commentary. This we are talking concrete method, concreting method. In you can say above, in order to achieve required quality of concrete, it is important to employ an appropriate construction method and carry out in reliable way. At design stage, structural details and various materials properties are determined, assuming use of widely used standard construction method. Widely widely used construction method. A as construction details such as construction requirements, weather conditions, environmental conditions and concreting related conditions become concrete and specific. However, it may be more appropriate to alter construction method. It's good practice, therefore, to take a flexible approach and select most appropriate method in view of conditions of construction projects. Decisions in construction methods in such cases may be made with reference to construction methods described in construction standards section. If a newly developed poor field tested method is to be used, it is necessary to conduct construction tests under realistic conditions in advance to fully ascertain quality of concrete in structures that can be achieved by that method. Determination of construction performance of concreting. Appropriate construction performance of concrete shall be specified according to construction method to be used. If construction performance of concrete cannot be specified, previously determined details such as construction method shall be reconsidered. Commentary. This time is 6:10. Okay. Construction performance of concrete includes work ability such as filling ability and pump ability. Work ability, which means filling ability and pump ability. Setting properties and strength development. that is pouring first, then setting properties and strength development properties. It's important to specify construction performance of concrete required at different stages of construction in due consideration of changes over time in properties of fresh concrete. Concrete with appropriate workability is easy to handle, pour and compact appropriately according to conditions such as placing, site, location, cross sectional shapes, and dimensions of members, and of course, reinforcing steel arrangements. Workability, however, is a property that can change over time at different stages of construction, from manufacturing, transportation, pouring, and compaction. Changes over time in slump vary considerably depending on concrete mix proportions, types of materials used, and environmental and weather conditions. During construction, workability must be specified. Therefore, after careful consideration, such time bound, time dependent changes says it is important to specify construction performance of concrete needed at different times, different stages of construction in due consideration of changes over time in properties of fresh concrete. Concrete with appropriate workability. With appropriate workability is easy to handle, pour, and compact appropriately according to conditions such as placing, see, placing, site, location, cross sectional shapes, and dimensions of members, and reinforcing steel arrangements. Workability, however, is a property that can change over time at different stages of construction, from manufacturing, transportation, pouring, and compaction. Changes over time in slump vary considerably depending on concrete mix, proportions, types of materials used, and environmental and weather conditions during construction. Workability must be specified. Therefore, after carefully considering such time dependent changes, in cases where concrete is pumped at construction site, it is desirable that concrete can be pumped at required rate under planned pumping conditions without incurrency, without encountering clogging of piping, and quality of fresh concrete be not severed affected by pumping pumping. Concrete with excellent pumpability in concrete is concrete that has a well balanced combination of three properties, namely ability to flow smoothly in straight pipes, fluidity, it is called fluidity, Let me speak again, because says pumpability, excellent pumpability is concrete that has a well balanced combination of three properties, namely ability to flow smoothly in straight pipes, fluidity, ability to pass through bent pipes and tapered pipes, deformability, and resistance to segregation due to well balanced combination of these properties, namely the ability to flow smoothly in straight pipes, fluidity, ability to pass through bent pipes and tapered pipes, that is deformability, and a resistance to segregation due to changing pressures in pipe, segregation, resistance. Setting properties are related to conditions such as compaction of concrete, compaction of concrete, lateral pressure acting on formwork, placement intervals, and timing of finishing. In case of hot weather concrete or cold weather concrete, it may be necessary to adjust setting properties appropriately to accelerate a retard setting or rart setting. Appropriate appropriate strength development properties are required to ensure safety of structure being constructed against loading expected during construction of structure, and achieve rational construction and required performance of completed structure. Just a minute, please. student. I just went to take some water. So what we say here? Appropriate strength. Appropriate strength. Appropriate strength development properties are needed, are required to ensure safety of structure being constructed against loading expected during construction of structure and achieve rational construction and required performance of completed structure. Concrete strength during construction is under influence of factors such as placing temperature. One important point is placing temperature, that is relative to concrete strength. Concrete strength during construction. Concrete strength during construction is under influence of factors such as placing temperature, material of formwork, curing method and ambient temperature. So these are 4 points. One is temperature, concrete temperature is placing temperature, formwork material, what type of curing you do, and ambient temperature. It's therefore necessary to take these into consideration when deciding on timing of formwork and false work removal. Strength development properties may be necessary in order to remove formwork and false work or achieve early initiation of pre-stressing tendon tensioning for pre-stress concrete. If required construction performance of concrete cannot be achieved, construction method must be reconsidered. For example, if required workability or pumpability cannot be achieved by carrying out a long distance pumping plan, it is necessary to revert to concreting method determination stage and make necessary changes such as changing concrete hauling method within construction site. Again I read, if required construction performance of concrete cannot be achieved, construction method must be reconsidered. For example, if required workability or pumpability cannot be achieved by carrying out a long distance pumping plan, it is necessary to revert to concreting method determination stage and make necessary changes such as changing concrete hauling method within construction site. Materials. Only materials of proven quality shall be used as concrete materials. Using appropriate materials is very important for producing concrete with required performance. Whether particular materials are suitable for use can be judged from test results or past performance data. In general, materials conforming to JIS, JSCE standards or other quality standards may be deemed to be materials of proven quality. It's possible, however, to meet performance requirements for concrete even if materials not conforming to quality standards are used. If such materials are used, it must be ascertained in advance that performance requirements for concrete structure can be met. Concrete materials of whatever quality may be used as long as concrete made by using those materials meets performance requirements. In case of poorly field tested materials, however, it is necessary to carefully evaluate their quality and performance of concrete, including long-term stability of quality and influence on durability of structure made of those materials. Concrete mix design. Concrete mix proportions shall be determined taking into consideration of such factors as constraints, related concrete plants, availability of materials, and economy, including transportation cost, so that required performance of concrete can be achieved. And commentary. Commentary says that mixed design refers to series of tasks. Mixed design refers to series of tasks performed to specify materials and their mix proportions so that performance requirements for concrete can be met. Usually in mixed designs process, materials and respective mix proportions are assumed and trial mixing is conducted or carried out, and this cycle is repeated until it is confirmed that concrete mixes made in this way meet all performance requirements, characteristics, values. Because there are many combinations of materials and respective mix proportions that meet performance requirements, what is to be done in mixed design stage is to select appropriate ones from these combinations. Performance attributes required performance attributes required of concrete here include characteristic values for concrete indicated by design and construction performance of concrete, conditions and mix requirements shown for reference only. Verification of concrete performance. It shall be verified, that is verification of concrete performance shall be verified that concrete made with selected materials and mixed proportions meets characteristics value criteria indicated by design. If design indicates reference only values related to construction, besides characteristics values, it shall be verified that selected materials and mixed proportions meet reference only values or meet concrete performance requirements on which reference only values are based. And comments. Commonly used methods of concrete performance verification as of this writing include experiment-based methods and methods of making inference from past performance data. Characteristic values for concrete to be verified include strength, carbonation rate. What are characteristic values for concrete? Being we have to verify that includes strength, carbonation rate, coefficient, diffusion coefficient of chloride ions. Important point, carbonation rate coefficient, how fast it is or how slow is it. Diffusion coefficient of chloride ions means how much they spread into this, penetrate into this. Freeze thaw resistance, chemical attack resistance, alkali silica reaction resistance, water permeability coefficient, fire resistance, and drying shrinkage strain. Again I say what we have to verify is number one, strength, carbonation coefficient, chloride ion diffusion coefficient, freeze thaw resistance, chemical attack resistance, alkali silica reaction resistance, water permeability coefficient, fire resistance, and drying shrinkage. Strain values indicated for reference only, such as material conditions and mix requirements. Workability, pumpability, setting properties, strength, development properties, etc. specified in construction plan also be verified. Is a criteria that can be used, and that is here. You can see that if I open full page, I can only clear that. Gamma P, AP over AK, AP divided by AK, gamma P, AP divided by AK is less than equal to 1 or same in place. Live with the term for gamma P, AK over AP, we reverse this denominator with numerator, so AK over AP is less than equal to 1, where AK is characteristics value for a performance attribute of concrete, characteristic value. AP predicted value. So AK is characteristic value for a performance attribute of concrete, and AP is predicted value for a performance attribute of concrete. Gamma P factor of safety for accuracy of AP, that is predicted value. If even a single characteristic value among specified value is not met, selected materials and mix proportions are altered and verified, and verification is performed again. So these factors are gamma P, that is gamma P factor of safety for accuracy of AP, and AP predicted value, AK is characteristic value. These three parameters work together in ratio reversal form, in division reversal form, and if this tells us, and if even a single characteristic value, how many percent of battery saved? Okay, it's just some time, no problem. If even a single characteristic value among specified values is not met, selected materials and mixed proportions are altered, and verification performed again. If rational mix proportions for concrete cannot be determined by this method, all conditions including structural conditions, reinforcement material conditions, concrete manufacturing conditions, placement conditions, and maintenance conditions shall be reconsidered. What? So many conditions, yes, structural conditions, we have to reconsider. That is a structural condition, that is all conditions, structural conditions, reinforcement material conditions, concrete manufacturing conditions, placement conditions, and maintenance conditions shall be reconsidered. Then we have confirmation and alteration of construction plan. It must be confirmed by an appropriate method that concrete construction plan must meets requirements for construction work, and that performance requirements for structure are met. Any change in construction plan should be made so as to minimize its influence. As a general rule, changes in construction plan should be limited to concrete mix proportions and construction methods. If construction plan differs from reference, values indicated at design stage, cracking checks at construction shall be made again under conditions of flattening construction plan. And comments: construction plan must meet requirements for construction work. Construction plan must meet requirements for construction work and must be such that concrete structure built in accordance with plan, down all video audio, but in accordance with plan, meet performance requirements. Contractor Contractor submits a construction plan in writing. Contractor submits a construction plan in writing to honor and checks honor checks. Contractor submits a construction plan in writing and honor honor checks, you can say honor checks whether structure shown in design drawing and specifications can really be constructed and approves construction plan. To be more specific, it is necessary to check each task in accordance with items and descriptions shown in table we discussed to determine whether standard construction methods specified in construction standards of this specification are used, whether plan has an adequate margin of safety against variable factors expected in connection with each task, whether plan incorporates troubleshooting methods, etc. If new technologies or new construction methods are to be used, it is necessary to evaluate respective feasibility and reliability by referring to reliable document or conducting full-scale field trials. If construction plan is to be changed, resultant changes in other conditions should be minimized. A realistic way is to stay within framework of reconsidering construction plan instead of reverting to design of concrete structure. Usually, making changes in concrete mix proportions or construction methods specified in construction plan suffices. At design stage, concrete and its placement methods are assumed. Checks are made on initial cracking and characteristic values for concrete are determined. If these conditions in construction plan differ from conditions assumed at design stage, verification on cracking shall be made again on an as needed basis at construction stage. Chapter 3, Construction. Construction of a concrete structure shall be carried out in accordance with construction plan. Construction of a concrete structure shall be carried out under supervision of a domain engineer with sufficient knowledge and experience in construction of concrete structures stationed at construction site. In our language, in English language or other countries' language, domain engineer can also be called discipline engineer. I think it's same, it's no problem. I understand it is same, but use your domain engineer if you like it, no problem. If construction plan cannot be followed at construction stage, appropriate measures shall be taken so that performance requirements determined at design stage can be met. And we see commentary of that. Basic rule for construction is to carry out construction work economically and efficiently by using an appropriate construction method on condition that construction safety is maintained. Because concreting work involves a variety of tasks, such as tasks related to formwork, reinforcing steel, and placing of concrete. It is desirable that concreting work be thoroughly coordinated with other types of work so that construction work can be carried out efficiently. To construct a concrete structure, constructor prepares a construction plan that details necessary construction processes based on design drawings and specifications. Construction of concrete structure therefore must be carried out in accordance with construction plan. In general, quality of construction is heavily dependent on human factors such as experience and qualities of constructors. It is very important, therefore, to station domain engineers with sufficient knowledge and experience in field of construction of concrete structures at construction site, so that construction work carried out under direction of those domain engineers. In construction project, incidents not expected at planning stage may occur at construction stage. It's not always possible, therefore, to carry out construction in accordance with construction plan. If it is difficult to follow construction plan in a real construction project, appropriate measures must be taken following domain engineers' instructions so that required performance can be achieved. Quality controls. Now, we'll take up it little later, let me read, but actually skills general in this is contractors shall perform quality control at each stage of construction in order to create a concrete structure that meets performance requirements. Quality control shall be performed as a voluntary activity of contractors by using a method that can be expected to be effective. If quality control has revealed a possible quality problem, appropriate measures shall be taken in accordance with domain engineer's instructions so that performance requirements specified at design stage can be met. Hold on a minute, please. Okay, we'll take up this issue later on. Let's now concentrate on how to do it. Let's concentrate on how to do it in fact. later on. Quality control we have reached, and now it's 2 hours. Today there was some problem, so I could not take 3 hours. No problem at all. We'll take up later on, and that is, where it is my, again I come back, and this is name Suraj Engineer _ engineer. You can use it at yahoo.uk. This is that my certification. This is quality file, coordination file, concrete, the specification you're talking in, and I take your leave now for today. Thank you very much, gentlemen.